All right, 14.2 for general math. We were talking about Euler circuits. It's spelled kind of funny, but it's pronounced Euler. An Euler circuit is a path around a graph, so the same graphs that we saw yesterday, that uses every um, edge of the graph exactly one time in order to go from one vertex to the next. So there needs to be an edge connecting every vertex, and they begin and end at the same vertex. So let's say we start down here in the bottom left at Q. We go up using an edge exactly one time. We get to a dot or a vertex, and then we use another edge to get to a vertex, and then we use another edge to get to a vertex, and we use another edge to get right back to where we started. So a couple of questions to ask ourselves. Did we go all the way around and start and finish in the same spot? Yep. Did we use every edge exactly one time? Yep. So is it an Euler circuit? You betcha. Got a couple other examples down here. P to S to Q to R to P. Would that be an Euler circuit? No, because there's no line connecting S to P right here. So I think it literally helps, or it helps to literally trace your finger along as you read, like kind of like I'm doing with my mouse right now. Already did this one. And then what about Q to P to S to R to Q to P to S to R to Q? So even though you start and end in the same spot, you are going over every vertex and every line twice, every dot and every line twice, and that is not allowed. And then remember the degree of a vertex, so the degree of any dot is how many lines are attached to it. So Euler's theorem is if every vertex of a connected graph has an even degree, then the graph has an Euler circuit in it somewhere. So let's find the degrees of this graph, of these vertices. A has 2 lines, B has 4 lines, C has 2, G has 2, F has 2, again, B has 4, E has 2 lines, and D has 2 lines. So if all of these points or dots or vertices have an even degree, so like 2, 4, 6, 8, 10, 12, etc., then we can find a Euler circuit somewhere in that graph. So an example of an Euler circuit here would be A, D, E, B, F, G, C, B, A. So even though we used the same vertice twice, that doesn't matter. We just followed every single line exactly one time. If you have any questions, let me know.